Good morning, grade 8s, and welcome to our grade 8 natural sciences lesson brought to you by WorksheetCloud. If you have a question during the lesson, send an email with your question to grade8@worksheetcloud.com. So, I am the WorksheetCloud grade 8 natural sciences teacher, and my name is Mrs. Ernston. Remember to take notes as we discuss things in our online class today. So please make sure you've got pens or pencils or something to write with, and your paper or your notebook or your file or your textbooks or whatever you're working out of during this time. And then also take this time to copy down our email address, and you can email any questions you have through the course of this lesson to grade8@worksheetcloud.com. So before we get started with our lesson, why don't we have a moment of calmness? So as you prepare for this lesson, get comfy wherever you are sitting, and quietly prepare your paper and pens and pencils, your books and everything you need. And now, spend the next few moments just taking 7 to 10 deep breaths, just so that you can calm your mind and prepare yourself for the lesson. Also, in the busyness of the day, let's just take those deep breaths just to calm our thinking and calm our minds and refocus. So, deep breath in, hold your breath, and deep breath out. And deep breath in, and hold your breath, and deep breath out. And do this about 7 to 10 times. So you can pause the screen in the video while you do that. And now you've had a wonderful time to refocus. So welcome back. Hope you're calm and ready. We are going to study mathematical relationships this lesson. So we're going to have a look at the relationships between density, mass, and volume. We'll practice working with the equation density equals mass divided by volume. Just need to remind you that we represent density with a capital D, mass with a lowercase m, and volume with a capital V. We'll have a look at the units of measurement that we can use for each of these variables. Most importantly today, we're going to focus on something new, which is calculating the volume of an irregular shaped object. And then we're also going to learn how do we identify an unknown substance based on using mass, volume, and density. If you have only joined us today, we are about 3 lessons into density. So please go back to our previous 2 lessons and just have a look at the concepts that we introduced there, because I won't be repeating them to you today, and I don't want you to feel lost or out of touch with the work and things that we are doing. So go back and have a look at those lessons, and hopefully you can catch up in case you don't understand what we do today. So here we have an interesting scenario. So the theme for the majority of our lesson, or the beginning part of our lesson, is gold. And we can find gold in bricks and bars and coins. And in actual fact, gold has been a form of currency for centuries. And what they used to do long ago is, in order to swindle people into paying for a brick of gold, swindle sort of means to trick people, what they would do is, instead of handing over someone a whole big piece of gold brick, what they thought of doing is they thought of making these bricks of gold, but instead of filling the inside of the brick with gold, they would fill the inside of the brick with another type of cheap metal. So let's say lead, and then they would cover that lead with gold. So the inside of the brick would be lead, but the outside of the brick would be gold. So you'd pick it up and you'd think it was gold. So they used to fool people when this was a form of currency. So what I want us to have a look at today is will this concept actually work? So lead is a dense substance, but is the density the same as that of gold? So let's start off by having a look at how to calculate the density of a lead cube if a cube of lead has an edge length of 2 centimeters and a mass of 90.7 grams. So here is our cube. So they've given us a hint, number one, that it is a cube, which means every single side is going to be equal in length. And they have told us one of the lengths is 2 centimeters. So there we can assume that the length and the breadth and the width is all going to be 2 centimeters each. So the first thing we need to do is we need to calculate volume. Okay, so the volume of a cube equals length times width times height. They've told us that it is a cube and the sides are 2 centimeters. So that means 2 centimeters by 2 centimeters by 2 centimeters. So 2 times 2 is 4, 4 times 2 is 8. So our total is 8, and then centimeters times centimeters times centimeters gives us centimeters cubed, or cubic centimeters. So that is how we're going to calculate volume. So when we look at trying to calculate density, the equation for density is density equals mass divided by volume. So density equals mass divided by volume. So mass they've given us, here is mass, but they didn't actually give us the volume, but they did give us information that would help us calculate the volume. So that's what we did. So we write the equation density equals mass divided by volume. Mass is 90.7 grams. The volume if we relook at that sum again, so density equals mass divided by volume. The mass they've given us, that's 90.7 grams, and the volume we've just calculated, that's 8 centimeters cubed. So 90.7 divided by 8 is going to give us 11.3 grams per centimeters cubed. So if we have a look at this, would it work filling the inside of the brick with lead and covering the outside of the brick with gold? Well, no, in actual fact, it's not going to work, because if you had to take this brick and put it into some water to see whether or not it was going to float or sink, or if you were going to measure it out, or if you were going to calculate it, you'd find out that the density of gold is actually 19.2. So gold is actually a little bit more heavier than lead. So I don't think that that plan would work. So how do we go about identifying the density of an unknown substance? Well, firstly, let us say you are given an amount of an unknown substance. Okay, so we're not too sure how much that is going to be, but whatever we are given, the first thing that we need to check that we can do is, can you determine the mass? So generally what you'll go and do is you'll use an electronic scale or a triple beam balance that you find back in your classrooms. Then you'll need to go and calculate the volume. So assuming it is a block, you can measure your length times breadth times height. If it's any other shape, you can use the mathematical formulas that you've been given. So that means in order to calculate the density, you need the mass divided by the volume. You've got your mass, you've got the volume, you can calculate the density. And then you can go and you can look up the density on one of the table of densities, and you'll be able to identify the substance. But you can't only look at the density, because some substances may have similar densities. It is important that you also look at the appearance and where you got the substance from to help you identify the unknown substance you have. So this here is just an example of density tables that can be drawn up and given to you. Just as a reminder, you do not need to go and learn these values. You will be given the density tables, or you will be given the densities to work from. Please don't think that you have to go and sit and learn all of these. So if you need these values anywhere during the course of the lesson, you can just pause the video and refer back to it. We are about 10 minutes into the lesson, so if you just refer back then, you'll be able to see the density values. So how do we identify the density of an unknown substance? So here is an unknown substance that I've given you. I'm sure looking at it, some of you could guess what it is, but don't be fooled. So yes, it does look shiny, but let's see if we can work out what it is. So the first thing you need to do is you need to determine, and in order to calculate the density, you need the mass and you need the volume. So the first thing we need to do is to determine the mass. So we will calculate that by using this electronic scale. So we will put our substance onto the scale, and when we put it on the scale tells us that we have 51.842 grams. So you can copy that mass down because we'll need it for later. So now we need to identify, in order to identify the density, we've got the mass, but now we need the volume. So it is an irregular shaped piece of substance, and it is a shiny yellowish color. But how do I calculate this volume? There's no length, there's no breadth, it's no particular shape. I can't use any of my mathematical formulas for volume. So what can we do now? Okay, so here is a fabulous little tool. We can use the displacement of water to calculate the volume of an irregular object. So the first thing you need is a graduated cylinder. So that's just a measuring cylinder that has got measured out mils. Some are mils, some are centimeters cubed. And then you fill the graduated cylinder up to a certain amount. So pick an easy figure. So in this case, we've picked 30 milliliters. And then you need to record that is your initial volume. Okay, then you place your irregular object. So in this case, your rock, our goldy, shiny yellow rock, you're going to place it in the cylinder. And that is going to cause the level of water to rise. So if we have a look here, our initial volume is 30. Once we've put the substance in and we go and read carefully, we now have a volume of 35 mils. So that's going to be the final volume. You then subtract the initial volume from the final volume, and that will be the volume of your irregular shaped object. So how cool is that? So please remember this method. You'll definitely use it today, and there are some practice problem sums in the WorksheetCloud worksheet that is attached that you can do when you finished listening to this lesson. So just as a reminder, when we are measuring water, when we're measuring any liquid in a graduated cylinder, to measure the volume of liquid in a graduated cylinder, you should make a reading at the bottom of the meniscus. That is the lowest point on the curved surface of the liquid. So when you pour a liquid into a cylinder, you will notice that that liquid makes a bendy shape like this, and that's got to do with another whole lesson on the surface tension and particles and how they combine. So when you pour the water in, the water makes a curved surface like that. And this surface layer of the water is known as meniscus. So we don't want to take the reading from the top here. So we're not going to take the reading as being 20, 21, 22. So you don't take it from the top there. We are going to take the reading from the bottom line. So we're going to take the reading here. So it looks like it's in between 21 and 22. So the reading in this case is going to be 21.5 mils. So just remember that. That's an important skill to have. So here we have a cylinder, and we have filled that cylinder with a certain amount of water. I think if we have a look, it will be about 17.1 mils. Then we're going to put our bit of yellowy, shiny substance inside it, and our water level goes up. So we started with 17.1 mils. That's our initial reading. And then our final reading is 19.8 mils. So if we want to find the volume, we need to take our final reading minus our initial, so that's going to be 19.8 minus 17.1. So the volume of our object is 2.7 mils. So jot that down. So now we've got the mass of our yellow shiny object and we've got the volume. So we've got the two figures that we need to be able to calculate density. So here is our shiny yellowish material. So we weighed it and we submerged it in a graduated cylinder, and here we have our results. The mass is 51.84 grams and the volume is 2.7 mils. So now we're going to take these volumes and determine the density. So density equals mass divided by volume. So 51.84 grams divided by 2.7 mils, and we get 19.2 grams per centimeters cubed. And if you go back in our presentation to the density tables and have a look there, you will find that it is most likely that the material that we have here is gold. And we say that because it also has the right appearance for gold. So a lot of you are probably right from the beginning. You said it was gold. And it is very close to the given density for gold. Density for gold is 19.2 grams per centimeters cubed. So because of that, we could probably assume that this shiny piece of material is gold. Okay, so here we have a fairly large piece of jewelry, and it has a mass of 132.6 grams. It also looks shiny and silvery. So you took a graduated cylinder, and initially you put 50 mils of water in, and then you submerged the jewelry, and the total volume increased to 62.62 mils. So the first thing I want you to do is to determine the density of this piece of jewelry, and then I want you to assume that this jewelry is only made up of one type of substance. And I want you to see if you can then refer back to the density table and see what the substance is most likely to be and explain. So we could make a guess that it's probably platinum or silver. Oh, sorry, I see there's a spelling mistake over there. I'm guessing it's probably one or two of those substances, but who knows? Maybe it's something else inside and sprayed shiny on top. I don't know. Let's go and have a look. So pause the video and see if you can do these calculations and come up with the answer. So the first thing we need to do is we need to calculate. We've been given the mass. It's 132.6 grams. So we need to calculate the volume. So the volume of the object is going to use the final volume minus the initial. So that's 62.62 mils minus 50.0 mils. That means the volume of the object is 12.62 mils. So now we have a mass and we have a volume. So we use our equation, density equals mass divided by volume. We're going to say 132.6 grams divided by 12.62 mils. And we get 10.5 grams per centimeters cubed. Now, if you go back to your density tables, you will see that the object is most likely to be silver. It has a similar appearance to silver. It also has the same density. So it's possible that the jewelry that we had was silver. So just to end off this lesson, what do you like in today's lesson? And was it easy? And what didn't you like in today's lesson? And was it difficult? So if you could just pause the video now and jot down your 4 answers to these 4 questions. It is a really cool reflection on the lesson, and it will just help you understand where are you in terms of density and mass and volume and understanding all the concepts. I'd also like you to go onto the worksheet that is attached to this lesson and complete those activities. The memo is also there, so you'll be able to see whether or not you are understanding the work correctly. If you are struggling, please will you go back and review our previous lessons. And then lastly, if you have any questions, please email them to us, grade8@worksheetcloud.com. It was so wonderful having you into today's lesson. And so grade 8, thank you so much for watching. The lesson was brought to you by WorksheetCloud. Bye for now. Look forward to seeing you tomorrow.